Okay, let's go ahead and add these two fractions together. And the problem is 3 over 560 plus 1 over 85. And the big question is, will this problem be easy? Now, of course, that depends on your knowledge and skill when it comes to fractions. So we'll just kind of table this question here for a second. But I'm going to show you two ways to do this problem, and you will decide which is the easier way. But I'm not going to kind of give you my opinion on whether or not this is going to be easy, because I want to give you a full opportunity to do this problem on your own. Now, here is an additional kind of twist to this problem. Put away your calculators. So no calculators. Now, as soon as I said that, I know a lot of you are like, oh, no calculators, forget it. I'm out of here. I'm not going to do this problem. This would be a lot of work. Well, maybe, maybe not. Okay, again, is this problem going to be easy? Well, maybe some of you might say, oh, if I have a calculator, it'd be super easy. But if you don't have a calculator, could you do this? Well, if you want to try it, pause the video, put your answer into the comment section. I'm going to show you the correct answer here in just 1 second, and then I'm going to show you two different ways that you can do this problem, and then you'll decide whether in fact this problem is easy or not. But before we get started, let me quickly introduce myself. My name is John. I have been teaching middle and high school math for decades. Really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. I'll leave a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer right now. So the final answer would be the following. 163 over 9520. So we got a big fraction here. Now, if you got this right, that is super impressive. Matter of fact, I'm going to give you a happy face, an A++, 200%, multiple stars. You can brag to your friends and family that indeed you are a professional certified expert in fractions. They'll be highly impressed with that information indeed. Okay, so if you didn't get this right, well, then maybe this problem wasn't so easy. And even if you got this problem correct, there is a decent amount of work involved. Okay. Now, when you're working a math problem, it's one thing to be doing work. It's another thing to be doing a lot of work and just kind of questioning yourself, like, do I even know what I'm doing? Because we get discouraged, right? You're like, I don't want to be doing a lot of work and just like be in doubt because then I'm going to be pretty confident I'm going to do the problem wrong. So a lot of students just kind of give up. They're like, I'm just going to quit. But if you know what you're doing and you know there's work involved and you're just kind of walking step by step to the final solution, well, that's the nature of mathematics. So let's go ahead and get into the problem right now. Okay, so the first thing I'm going to suggest is the following. So notice how I wrote the fraction here, and I'm using these angled fraction bars. Now, stylistically, there's nothing wrong with that, but if you like to write your fractions this way, I'm going to encourage you to write them in this way. Okay, it's just a little bit better way, in my opinion, to write fractions using a horizontal fraction bar, especially for those of you that are going to be studying algebra, or maybe you're in algebra right now. Okay, so if you like writing your fractions this way with the angled fraction bar, that's not a problem. Okay, there's no issues there, but try to get in the habit of writing your fractions this way. All right, now looking at this problem, we're adding two fractions. So when you add and subtract two fractions, we cannot do the problems unless the denominators, which are the bottom numbers in the fractions, are the same. Now clearly, these two numbers are not the same, so we have some work to do here, but let's take a look at an easier example, okay? So if I was adding these two fractions, 1/9 plus 4/9, I'd be like, okay, I'm adding fractions, that's what I want to do. So your eyes should go to the denominators. And you're like, okay, this number is the same as this number, no problem. So to do this problem, to add two fractions where the denominators are the same, all we have to do is add the respective numerators, which are the top numbers. So 1 plus 4 over 9. Of course, 1 plus 4 is 5, so 5 over 9 is the correct answer. Okay. Now, of course, that's not our situation because the denominators are different, so we're going to have to do some work. Now, let me show you another great little shortcut method here. As a matter of fact, I'll hold off on that shortcut in just 1 second. Let's go ahead and continue on. Now, let's take a look at a situation where you have to find the LCD. I'll show you this shortcut here in just 1 second. All right, so in this particular situation, we have to find the lowest common denominator. And this is where a lot of students just don't like fractions. I'm pretty sure, myself included, way back in the 1970s, you're like, I hate fractions. I don't want to do this stuff. Listen, I get it. But in this particular problem, you are saying, okay, the denominators are different. I can't add them. So I have to think of that LCD thing, the lowest common denominator. And most of you could look at this problem and say, okay, the LCD is 15, right? And typically, the way a lot of students will think about it, they're thinking about the lowest number such that these two numbers can divide into without a remainder. So like, okay, 5 goes into 15 without a remainder, and 3 goes into 15. So the LCD is 15, and that would be correct. However, you're kind of, you're just kind of, what's the word of lack of a better word, not guessing, but you just know what the LCD is with these easier denominators. It becomes a different situation when we are going to do the problem that we're going to be doing here in just 1 second. But again, here the LCD is 15. So what does that mean? Well, it means that we have to change these denominators into 15 to do this problem. So let's go ahead and do that right now. So how do we do this? Well, let me go ahead and show you the entire work here. So here is our fractions, 2/5 plus 1/3. We have to change a 5 into a 15. How can I change a 5 into 15? Easy. Just multiply it by 3, so 3 times 5 is 15. But if I multiply the denominator by 3, I also have to multiply the numerator by 3, so 3 times 2 is 6. So all you're doing here is changing this fraction into this fraction, 6 over 15. So you didn't break anything. These two fractions are equivalent. Matter of fact, if I said, hey, here's a fraction 6 over 15, can you reduce that, simplify that? You would write this fraction, okay? So the idea here is you're just rewriting the fraction in a different way such that the denominator is the one that you want. In this case, it's 15. Okay, so here we have 1/3. We need to change its denominator to 15. So how can we change a 3 to a 15? Just multiply by 5. So 5 times 3 is 15. And then if we're going to multiply a 5 by the denominator, we have to multiply a 5 by the numerator. So we end up with the fraction 5 over 15. So at this stage, by rewriting these fractions such that they have the lowest common denominator, we can just simply add the numerator. So 6 plus 5 is 11 over 15. Now, most of you hopefully are like, yes, Mr. YouTube Math Man, I'm an expert at this stuff. Get on to the good stuff. Well, I will in just 1 second, but I just want you to just a quick review for those of you that, are just, maybe a little bit rusty on fractions, because the problem that we're going to be doing here in a second is a little bit more interesting than this basic fraction problem. Now, I'm going to show you a cool shortcut. Okay, this is something you definitely want to know when it comes to adding and subtracting fractions. But before I do that, if you have not yet subscribed, you just don't even know how much this helps me on my YouTube channel. And I've been really grateful lately, getting a lot more views and what's super exciting. I've been on YouTube for many, many years. I think I have over 2,000 plus videos from basic math to advanced math like calculus. So, for me, I just love teaching math. I'd be on YouTube no matter what. But when you do subscribe and you hit that notification button, it helps me tremendously. So if you could do that little favor for me, that would be much appreciated. All right, back to the problem. So again, I kind of mentioned that there is a shortcut. Now, when we're adding and subtracting fractions, there's a method. I like to call it the bow tie method because it looks like a bow tie. So here, let me draw a little stick figure person here. And if you know what a bow tie is, it's one of those little things like that. Some of you might be saying, I bet you wear one of those, Mr. YouTube Math Man. No, I do not. I'm not, yeah, I think they're pretty cool, but I just don't wear too many ties. But that's what a bow tie is. Now, why am I stating that? Well, I just want you to kind of remember the pattern, okay? This kind of pattern like so. So when you're adding and subtracting fractions and your brain just doesn't want to work, you're like, you know what, I really don't want to do any math, but I got to get this problem right. I don't want to think about the LCD. Well, then you can do this bow tie method. And this is an awesome method for adding and subtracting fractions, and it's awesome in algebra as well. So here is how it works, and you have to follow this very specific pattern. All right, so here we got 2/5 plus 1/3. You're going to take this 3 and, well, you're going to start from the bottom right. So whatever fractions you have, you're going to start from the bottom right fraction. In this case, it's 3. And you're going to multiply diagonally like so. So it's going to be 3 times 2. Okay, so 3 times 2 is what? 6. So you're going to put that there. Now, because we're adding fractions, you're going to put plus. And then we're going to go from this denominator, the bottom left, and we're going to multiply in this crosswise. So it's going to be 5 times 1, which of course is 5. So this forms our numerator, and to get our denominator, we just simply multiply across, so that'd be 5 times 3 is 15. So 6 plus 5 is 11 over 15. That's the same answer, okay? If you notice what we just did over here, okay, with all this work, we got 11 over 15. But in this case, we had to do all this LCD stuff and change all this stuff around. Over here, all we had to do is follow the bow tie method and go this times this, 3 times 2 is 6, 5 times 1 is 5. I'm going to add these together. This is addition, that's my numerator. And then 5 times 3 is 15. Boom, 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 11/15, done, right? So pretty cool method. And a lot of you are like, oh, that's awesome. That was that was worth watching, this video for. So don't leave yet, okay? Because we're going to see how we can use this method in a second. But now we're going to get to the good stuff, right? So here is our problem. And the main question of this video was, is this an easy problem? Okay, well, even for you fraction experts out there, this is not that easy of a problem. Okay, there's a decent amount of work here. So the first thing we notice, right, is that we do not have common denominators. And so we're going to have to find a common denominator. So we're going to have to find the LCD. Now this is very much different than our situation like 3/5 plus 1/3, where you're like, oh yeah, the LCD is 15. I'm an expert in LCD. Well, great. Tell me what the LCD is right here. Now, when you give students a problem like this, a lot of students just can't figure it out. Okay, they can get common denominators, but they may not know exactly the procedure to find the lowest common denominator. Now, if you do know the procedure, that is fantastic, but I'm going to show you the procedure right now. Okay, so here is how you find the LCD of any denominator. So if you have 2 denominators or maybe 3 or 4, doesn't make a difference. So what you want to do is you take the numbers, the denominators here, and we want to factor them. Okay, we want to prime factor. In other words, we break these down, and a great way of doing that is using a factor tree. Let's start with 85 because this is pretty simple, and then we'll move on to 560. So 85, you just start thinking, okay, what 2 numbers, go into 85? Of course, 85 ends with the 5, so we know it's divisible by 5. So 85 divided by 5 is 17, so 5 times 17. These are both prime numbers, so we circle those factors. Okay, so we can't go any further because these are prime numbers. So we want to factor until you reach all prime factors. So 85 is equal to the prime factors of 5 times 17. All right, how about 560? Well, let's break this up. And the easiest way to start factoring this is 56 times 10 because that's 560. But these are not prime, so we're not going to circle those numbers, right? We're going to continue to factor. So 10 we can factor as 2 times 5. Those are prime numbers, so we'll circle those. And then 56 is 7 times 8. 7's prime, so we'll circle that. 8 is not, so we can continue on to factor 8. And let me show you the rest of this work here. So 8 is the same thing as 4 times 2. 2 is prime, so we'll circle that. 4 is not, so 4 is 2 times 2. So now we have all the prime factors, right? So it's 2 times 2 times 2 times 2 times 5 times 7 is 560. Okay, so those are the prime factors. So we have 1, 2, 3, 4, or 2 to the 4th power times 5, this 5 right here, times 7. All right, so that is 560. So we're going to express our 2 denominators by their prime factors. So, and we want to use powers as well. So instead of 2 times itself 4 times, you're going to write this way: 2 to the 4th times 7 times 5, and then 85 is 5 times 7. So this is a good amount of work, obviously. But this is not a easy problem, all right? So there I said it. There's the answer. Will this be easy? No, not really, okay? It's, especially without the aid of a calculator. It's a lot of number crunching. Even with a calculator, you still need to know how to do this. Okay, so let's figure out how to find the LCD now. Okay, so here's what you need to do. You need to have every single prime factor between these numbers, okay, the respective denominators, in your LCD. So for example, I have a 17 as a prime factor. That's got to be a part of my LCD. I have a 5 here, and I also have a 5 here. So we just need one of these numbers represented in our LCD. So if there's a 5 here, there's a 5 here. We just need one 5. Oh, we have a 7. That's got to be in our LCD. And then here we have a 2 to the 4th. That has to be in our LCD. So now we can go ahead and actually do this arithmetic. Let me go ahead and do this here. So 2 to the 4th is what? That's 16. That's 2 times 2 times 2 times 2. So this is 16 times 7 times 5 times 17. That's 9520. Now, I know a lot of you are like, okay, I'm done. I'm gonna unsubscribe. You want me to subscribe? I'm like, I hate this. Well, listen, if you can follow me, if you can learn what I'm teaching here, you're going to really strengthen your fraction skills. So stick with me, even though you don't like this stuff. You'll be like, ah, okay, all right, I'll give this guy a little bit more time. So stick with me. All right. So this is our LCD 9520. All right. Now, again, remember that procedure for future prompts. So that means here is our original prompt, 3 over 560 plus, let me kind of fix this plus sign, plus 1 over 85. So what we need to do is change these denominators or change these fractions such that we have 9520 as our denominator. So how do I get a 560 into a 9520? Well, you have to kind of guess and check, but you have to multiply by 17. So 560 times 17 will get you here, and 85 times 112 will get you here. So that means I'm going to have to multiply the denominator and numerator by 112 on this fraction. On this fraction, I'm going to have to multiply the denominator and numerator by 17. So obviously a decent amount of work indeed. But there's another approach that you could take, okay? So here is our fraction. I know this is kind of confusing, but this, if you can learn this, it could definitely save you time. So our current fractions are 560 and 85 in our denominators. Now remember when we did our prime factoring, 560 is equal to 2 to the 4th times 7 times 5, and 85 is 5 times 7. So we know that our LCD is this number right here. Remember we built that out, and let me go back to it right here. So our LCD is 2 to the 4th times 7 times 5 times 17, right, which is 9520. But I want to see that LCD factored, okay? So all this right here is 9520. So we're looking at the LCD in terms of its factors, okay? So hopefully you're not too confused. All right, so let's go down here. So this is our LCD, okay, and this is our LCD, 9520. So what we can do is look at our denominator, 560, and just look to see what's missing. I have a 2 to the 4th. I have a 2 to the 4th here. I have a 7 here, a 7 here. I have a 5. I have a 5 here. But look, from this number, I'm missing a 17. So this is where I'm going to have to multiply 560 by 17 to get to change that number into the LCD. Okay. Now 85 is 5 times 17. This is the LCD, so I have 5 and I have 17, but I'm missing 2 to the 4th times 7. Okay, so these are the numbers that you're going to have to multiply both the numerator and denominator by. Now, some of you might be a little bit overwhelmed here. If you are, you want to practice with easier fractions. This is definitely a pretty challenging problem, no doubt, especially without the aid of a calculator. That's why I gave those of you that got this right like 2,000%. Matter of fact, if you're in my math class, I would just say, you know what, don't even come to school. Here's your A plus for the year. I'll see you next year. Okay, so let's go ahead and see how this works, right? So we figured out that to change 560 into the LCD, we're missing the 17. We're going to have to multiply this by 17, and 85, we're going to have to multiply 85 by this number, 2 to the 4th times 7, so 16 times 7, right, which is 112. All right, so that's one way you could do that if you didn't want to kind of like think, okay, 560, times what will give me 9520. So it's going to be 17. So we'll multiply both the numerator and denominator by 17. So we get 17 times 3, or 51 over 9520 for this fraction. And then 85 times 112 is obviously 9520. And 112 times 1 is this right here. All right, so finally, after all this work, we have the same denominators. We can simply just add the numerators. Okay, so let's go ahead and do that finally right now. We'll have the right answer. So same denominators. So all we have to do is add the respective numerators. So 51 and 112 is 163 over 9520, and we are done. All right, so was this easy? No. Okay, this is not easy. It's a lot of work, but if you could do a problem like this, I mean that is fantastic. That means you truly, truly have mastered the skills when it comes to adding and subtracting fractions. That's why I kind of, put this problem out there, a challenge problem. Now, there's a different question. Well, it's like, hey, it could we make this problem easier? Well, let's go ahead and take a look at the bow tie method for this particular problem. Okay, so here we could just be like, hey, that guy told me about the bow tie method. I could take this number, multiply by this number. I can add that to this number times this number over 560 times 85. Let's see if that's easier. Well, you be the judge of that. So let's see the work. So it's going to be 85 times 3 is 255. That's not too bad in terms of multiplication. 560 times 1, that's super easy. That's 560. And then 560 times 85 is 47600. Okay, so now let's go ahead and clean up the numerator. 255 plus 560 is 815 over 4760. Now we are pretty much done. The only drawback with the bow tie method is oftentimes, your answer will not be fully simplified. So you have to reduce this fraction or try to reduce it. Sometimes it is, sometimes it isn't. But this is really easy. You're like, wait a minute, this number ends in 5. This is 0, so this number is divisible by 5. And this number I can divide it by 5. So when you divide 815 by 5, that's not too difficult. Look what we get, 163 and 47600 divided by 5, we get 9520. We are done. Okay. So, the bow tie method is a fantastic method, but in algebra, okay, you're going to have to know, and in arithmetic, how to find the LCD, and you should really, really know this bow tie shortcut method. It's very important. So, again, it's a good reason why a lot of students don't like fractions because it's a lot of stuff, right? But you have to make friends with fractions. It's like that scary dog that lives down the street from you. It's always barking and whatnot. If you just go up to it, maybe, and make friends with it and just, maybe it'll stop barking at you. Same thing with fractions, okay? You just have to take it one step at a time. Don't get overwhelmed and try to have a different attitude towards learning things that you don't like, right? Because if you're like, I hate this, I hate this, I hate this, well, your brain's going to tell you that you don't want to learn this. And as soon as you're saying, all right, I'm going to learn this, I'm just going to just take it one little skill at a time, then you're going to be successful. Now, if you need help with fractions and basic math, check out my Math Foundations course. I'll leave a link to that in the description below, or my pre-algebra course. I also have a ton of additional videos on fractions on my YouTube channel as well. Okay, so with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time, and have a great day.